next presenter is Sin Lin from Norwegian University of Science and Technology, and the presentation is entitled Advances in Machine Learning-Based Disaggregation of Building Heating Loads, a Review.
Thank you. Right, I am presenting this on behalf of myself and my co-authors, Behzad Najafi from Politecnico di Milano, and my supervisor, assistant professor Jay, is over there, so he can answer questions as well after this. The topic of this paper is advances in machine learning-based disaggregation of buildings' heating loads. So I'll just jump into why we are so interested in energy use for heating loads in buildings. If you see this top figure here, this is the electricity consumption every hour for 1 year in Norway. And the green line below is the outdoor temperature inversed. So the Norwegian energy system is a bit special, as the temperature has a big impact on the electricity consumption. We have a bit of a high base load, which is electricity used in industry and for transport and non-heating or temperature-dependent electricity loads. But we see that the majority of the peaks and the variation in the electricity throughout the year is very much dependent on the outdoor temperature. And the reason for this is that we use a lot of electricity for heating of buildings, which is quite special. Actually, most buildings in Norway do have electric heating equipments. And at the same time, we know that electrification of all sectors, industry and transport alike, is important to achieve a more sustainable energy system. And electrification processes have started, are well on their way in industry sector and the transport sector. And we see on this table below here, this shows the peak loads, so the maximum consumption of electricity for every year for the past 12 years. And we see that the trend is that the peak load is increasing. So the electricity consumption is increasing. It's expected to become even higher. And the trend for the temperature at the same time is going down. Since the peak load is expected to increase with more electrification, we want to figure out a way to limit this peak. And the key in this example is to limit the electricity that goes to heating. And to do this, we need to get more information about when are heating equipment being used in buildings, so we can act on different measures. We could supply a lot of meters to different buildings and mechanically find out when different heating appliances are using different heating or electricity. But this is time-consuming and expensive way. So a more clever way is to use data-driven approaches. And this is not a new field. Disaggregation of electricity loads into different household appliances has been a field since the 1980s, specifically with a field called non-intrusive load monitoring, which is pattern recognition of electricity loads of high frequency. And this field is developing a lot, especially we have seen that in the past years, deep learning is getting increasingly popular in this field. So what we wanted to do with this literature review is to find out what is the state of the art today in the field of disaggregation of specifically appliances for heating. So we want to take the smart meter data for electricity and break it down into heating appliances. So the scope of our literature review is to look at what have other review studies looked at within this field, what are some commonly used data sets used in this research. And we also go through available research on the topic, research that have disaggregated heating appliances. And we have sorted them into different categories. I'll get back to this. And finally, we look at what are the data requirements to be able to do disaggregation of heating appliances from total electricity loads. The method is quite standard literature review. We did first a large search through open libraries. First, we extracted about 2,000 articles, which were later reduced to about 200, and screened, where we looked at disaggregation of heating appliances from building electricity smart meters and available data sets. We also tested available toolkits, specifically NILM-TK and NILM-TK-Contrib. We found, or have mentioned, 6 other review articles within the field of disaggregation and non-intrusive load monitoring on building energy loads that look up machine learning and other sort of applications. But the contribution of our paper specifically is that we are the only ones that focus specifically on the space heating appliances and disaggregation of these. We did in our study do an overview of datasets which are commonly used. A lot of studies that look at disaggregation methods use the same datasets. And there's a good number of reasons for this. Collecting new data is expensive and time consuming, and also using the same datasets works as a good benchmark. So we have in our paper made this overview of these 26 datasets where we give location of the datasets, the number of buildings which are available, the duration of the measurements, sampling rate, and also we have added what kind of appliances are available, so specifically if there are heating appliances measured in the datasets. Then we went through the available literature of the papers that we thought were particularly interesting. So for those who are particularly interested and wants to go and look at this paper later, we have made a table where we compare all of these, where we let you know what kind of work has been done, when it was done, what kind of data sets they used. So it's easy to systematically look up the differences between these approaches. So I'll give you just a summary of our major findings, because we see that there are a lot of different methods for disaggregating appliances and heating appliances. We found or looked at 7 articles that used traditional sort of machine learning methods, which includes regression methods, optimization methods, clustering, and decision tree methods. And we saw that these methods are easy to interpret. You know what's going on. They are computationally efficient, and then can be trained on small data sets. But on the other hand, we saw that deep learning or models and neural networks did usually have a higher performance on being able to correctly disaggregate electricity for heating appliances. We looked at 17 articles that did use deep supervised learning methods. Most of them looked at or were applied to high resolution data. So this is data with 1 second measurements of electricity use or even higher. And one of them was a low resolution application. A few of them, but most of them do not consider ambient conditions. So you only take into account the patterns of electricity, voltage, current, so the energy patterns, but you don't look at, for example, indoor temperature that you know will have an impact on heating appliance electricity use. But the benefit of this method is that in these applications, they did have a quite high performance. But on the other hand, as we know it, most deep learning applications that do require large data sets to train and are computationally hard or require a lot of power and time. We also saw that there is one emerging field within disaggregation, which is reinforcement learning approaches. We found 2 papers on this. And the benefit of this method is that you can you start with a small data set and improve the methodology as the data set grows. But for now, there is few applications within this field. So some conclusions that we found, there is several approaches for disaggregating heating appliances. But we see that most of these approaches, they disaggregate or look at data sets that have houses with just one heating appliance. So none approaches have been applied to buildings where there, for example, is used both a heat pump and an electric boiler, which is quite common for a lot of building with electric heating. We saw that the majority of the papers that we looked at, they are using the same data set. So they're looking at this data set called AMPDS, which disaggregate a heat pump. So it would be nice to have more studies that look at other kinds of buildings to compare the findings and to see if these methods are applicable to different kinds of buildings and appliances. We saw that deep learning methods are promising and often give good results. But we see that most methods applied today are applied to high resolution data, so 1 second or higher. And that these are methods that cannot necessarily be applied to applications with low resolution data. So when you want to disaggregate smart meter data, you need to have a different approach where you look at more data which is not or a bit it's a bit new or has not been researched as much in our findings. So yeah. So to conclude, we need to have different methods for high and low resolution applications of disaggregation. And here's my contact information if you need me, and I'll be here all week.
Thank you very much for the presentation. Any questions in the room? Yes.
Good. Very nice paper. And I'm laughing because of we have one PhD student. He just published a conference paper, similar topic. So first, I have basically two questions, and with the same topic. Is this 200 articles you look at is all a full text or only abstract? And you also mentioned about several articles regarding this different method. I think it's around 30, less than 30. So what's the rest of the articles what they talk about the method?
Yeah, thank you for your question. We ended up excluding quite a lot of papers because they didn't give specifically results on the performance on heating appliances, for example, or yeah, just generally for all appliances.
Any more questions?
Thank you for your nice presentation.
Thank you.
I was wondering, from what you've seen, how do researchers tackle this approach? Do they go for unsupervised or supervised learning? And in the case they go for supervised learning approaches, like how do you see the dilemma that you'd need to do heating load disaggregation because you don't know, but still you need to know to get the algorithm to know, if that makes sense. I'm sorry.
Yeah, sure. Yeah, I get most of these use supervised approaches. I don't know, Jay, do you have anything to comment on the unsupervised methods? No. Yeah, it's mostly supervised methods, as we see. Yeah.
Thank you.
Any more questions? I may have a question as well.
Okay.
Like for the deep learning algorithms, you mentioned that you need a lot of data. How much data do you need exactly? Like, is it just a couple of months? Is it 1 year? Is it several years? And like sometimes in buildings also you have changing conditions. Like maybe you're gonna play with the control. So how do you find the trade-off between like the size of the data set and the like data that must be representative of the actual operation?
Yeah, thank you. We see that most of the papers that we looked at here, they use data sets that have a really high frequency, so maybe a month or more. Yeah, depending on if you want heating appliances like we do, you definitely need a winter months to be able to do that. So not all data sets can be used either. So yeah, in our work, we collect at least a year for this. Yeah.
Thank you. Any more questions? Thank you very much.
Okay, thank you.